Oh yes, welcome back, guys. Let me invite some people in, right? Because it'll be better if there's more people in the house. We're going to be looking at direct information and devices that are free energy, and this is the real thing. So this is going to be the central place. This guy, this guy is a genius. He's one of my idols. Not that how can I say this? He has the videos that I would like to be able to have, which you know what I mean, in the sense that I've been trying to explain to you guys, but he has so many videos that explains it well to you. So I want to promote his videos, right? And I'm not going to play his videos because we're maybe little segments here and there. I want you to go on his site because he's really amazing. For example, this battery that he has in front of him is the same device that I produced, which is called the tower cells, but I didn't know of this device. And it was invented in the 18th century, and it's been working for 200 years. I called it the tower cell, but I didn't make one like this one. This one has 2,000 volts. It's of static energy. Now, you can't get more free energy than that, in the sense that with multiple devices like this, you could kind of produce most likely all the energy that you need. But most important is the concepts that we can work with to attain our goals. So let's listen to the intro of this, because it is the same thing as the tower cell that I make, and but not exactly the same way. I use more oxide materials, but it's the same thing. So
extreme batteries that you may think are really interesting. First, we'll start with the old school. This one's called the Oxford Electric Bell. It was built 193 years ago by some instrument makers, Watkin and Hill in London, and then 15 years later, in 1840, it was purchased by a physics professor at the University of Oxford and set up on display in the physics lab. These are dry piles here, and of the materials at the time, they probably used something like silver foil, zinc foil, or maybe copper foil and zinc foil, and a piece of...
I don't know, but maybe he's describing my tower cell when he's trying to describe. You never know, because I don't know. It'd be just funny, it's like a loop to loop. He's like, I think he's describing something that he knew about, but maybe he's describing my tower cell, and in figuratively of speech, maybe he saw one of my videos, who knows, but it would just be funny.
Paper or fabric in between those that was coated with light paste of maybe manganese dioxide, which was some material that was available at that time period. And there's about 1,000 of those in each one of these dry pile stacks here. That's a lot. And then what they did is they put a bottom and
so basically it's layers of paper, but in copper, and with oxide on it, and then a separator, and then aluminum, and then maybe some graphite, and another oxide. You're building a battery, basically, but it's a battery that you don't need to be charged.
And top piece here, you can see the 4 pieces. You can't see the one in the back, but it appears to have I guess a string. I thought it might be a wire, but it looks more like string here, that tied very, very tightly to compress these things. And then once it was compressed and tied off, it was coated in molten sulfur to lock in whatever moisture might have been in the manganese dioxide paste. So that's just what supposedly it's made of. Nobody really knows, because since 1840, it's been running constantly. And so they figure that the bell has rung 10 billion times. It's just amazing. And what it does is these are connected in series. Again, we can see up here that on the connection on the brass arch here. Also, you can see this is a silk fiber that's tied off here. You can see it hanging down here. It goes down to the little bell clapper. But they're in series, so what it would do is terminate in one of the bells being positive and the other being negative. I don't know which is which. But it's an electrostatic device. 2,000 volts this thing made when it was new. I don't know what it makes now, but it's probably still pretty high. And each time it rings against one bell, it consumes 1 nanoamp. So there's really no current. This is all electrostatic, just high voltage. And so what it does is when the little ball clapper hits one of the bells, it's charged according to that bell, and then repelled, and then it hits the other bell, charged accordingly, and it goes back and forth and oscillates at about 2 hertz. Being an electrostatic device, the problem with this is humidity is its enemy. It has, on occasion, I've read where it has stopped a few times for a short period of time because the humidity levels, apparently in the room, became excessively high, and any electrostatic device isn't going to work well when there's any kind of humidity at all. Much like having your shoes shuffling along on a carpet on a winter's day when the air is cool and dry, and you can touch something metal, a doorknob, or someone else even, and get a little spark off of that. Well, that's the conditions that electrostatic devices like the most.
Yes, but that also could be combined with other energy devices. Okay, this is very cool. So this is we could say, kind of a confirmation of my own tower cell and of the principles I've been talking about. It always existed, basically. So, but here is another one that he made. And this one, my friends, is a different concept because it does include magnets. And it's been running for 2 years. And he says that to light up that little light, and maybe has something else in there, it cost him a lithium battery 3 days before it discharges at 3.7 volts. So, but basically, that's to compare his load. So you would need to charge that lithium battery, 200 times for it to stay on for 2 years. And his device doesn't even need to be charged, and it stays on. It's been on for 2 years.
Bells that are in the Oxford electric bell is they both use 2 dissimilar metals and an electrolyte. This, on the other hand, has very, very thick alloys. One's an alloy metal, the other is graphite, but it has alloy in it. And it's 1/2 inch by 2 inches, very, very thick plates. And this actually makes current, and it'll light this LED, whereas the Oxford electric bell is electrostatic and only has specific applications that can be useful for. So, but if you take 4 of these and put them together, you would come up with this size, which is 2 inches square. You divide this into 4 pieces, and you've got the black parts that you see inside there, these cells. Now, the chrome parts that you see are neodymium magnets. They're exactly the same size as these cells, because when I made this in November of 2015, I didn't really want a mechanical compression because these cells need to be compressed to get the maximum usefulness out of them. All the large ones that I make, I use nylon nuts and bolts to hold them together nice and tight. But in this case, it was just one of the test devices I was making in the fall of 2015. So I used these Neos and made the cells the same size as the Neos. And it holds them really nice. In fact, it gives them a chance to expand in case they were going to do some odd thing like the copper zinc and copper magnesium cells that you may have seen with bunches of salts and stuff. And those things just blowed out and ruptured. So I thought, okay, well, this will give it some expansion if it's going to do that. But after 2.5 years of running an LED, powering the LED consistently, it hasn't done anything. So we're doing good so far. It's pretty cool. I mean, it looks just the same. I did take this cell, I did take the LED off a couple of times when I did some extreme tests on the cells themselves, put them in the freezer for a couple of hours. And
For example, my tube cells, they perform a bit better than this, and they cost just a few dollars to make. This device, though, is more solid built, but it's expensive to build. Those lithium magnets are probably something maybe around, I don't know, $5 each. So he's got like $30 of magnets, plus his copper, his graphite thing there that he uses. That is maybe not so expensive, but it's most likely $10, if not more. So we have a device, you know, in the range of $40 to $60, well, Canadian, maybe a bit less US, but just to give us a ballpark. And it only lights up at one LED light. So basically, how many of these would you need to build? But he uses this in combination with crystal cells that he builds, which are the equivalent, and even the way he makes it, they're better than my tube cells. He's more advanced than me. He's been doing this for longer than me. And I didn't have any education, in the sense nobody told me. He maybe knew some things that I didn't know when I did my stuff. You know, he's very advanced. Been doing this for 10, 15 years. I don't know how long, but very long. Very genius in his understanding. And it's quite surprising that his videos, right? He has a lot of views, but for the genius that he is, right? And the videos are very well explained, right? His views, 15,000, is very low. Published last year, but he made it 2 years ago, so now it's been on for 3 years, most likely. The importance of this is that you got in the 1820, when they made these, right? They made like 1,000 layers. I keep saying it in my videos, you know, make 1,000 layers, make layers. I've been saying it for years, right? Nobody's listening, right? And right, it's like him. I'm even worse. I got no views. We're sharing important stuff, you know. Back in the day is back in the same way I did it, in the sense that we don't know. I didn't know what I was doing. I just went along with what seemed to work. So we discover things and we create things that are out of the boundaries. Right? So if they built many of these devices, the amperage maybe that you need to add to it is very little to get it to do more and more stuff, right? Because you're creating free voltage. So you add up 2,000 plus 2,000 plus 2,000. You end up with high voltage devices. For example, they had a phaser, right? If they had, I don't know, 10 of these, it would be the equivalent of a taser. Now, a taser in the 18th century, I mean, is something, you know what I mean? It's like, it's an advanced device. If you're able to have a taser, you're able to create heat, you're able to create light, because it does create heat and light. Now, you got a plasma arc. And in a creative mind that doesn't know what he's doing, and nature's got a way to do what he'll think that he wants to do. There's always a way. Nature, if you can think it, there's a way to do it. Maybe not the way you're thinking of it, but there's a way to accomplish, and you'll get there, you know. So that's what happened to me in that. in that sense. What is very interesting is when a conscious person discovers it on his own, then everybody has the right to build anything that they want. So even if there's patents of this and that, in a community setting, everybody's allowed to build one device for their devices that they want. So no laws could stop you. Well, not in Canada, maybe in other countries. But so that's the interesting part. And I won't go too much into it, but anyway, you get the point. This is important. His little box here that he made, right, is a combination of these plates that he's doing, and I don't think he even puts magnets in it, right? And here's the plates, and like this is like the advanced version of the tower cell. You know, he more than discovered that he has better techniques. He's more advanced. So it's not about really who did what when. It's really about being able to discover it for yourself. When you have when you can come up with it for yourself. So that's one of the reasons, you know, that could be tolerated, that not everybody knows this, because it should be discovered in a way by yourself. You like right now, you're discovering this, but that doesn't mean anything unless you in your consciousness know more about reality that creates a new reality. It's about what you can integrate in your life. Everything is out there. Let's say you can integrate your UFOs, then that means that you can have one. Because you're aware it can be created, so then you can create one. It might take you a while, but it becomes possible. But you must first accept that it is real. So let's go directly into something amazing. I put some clips aside, especially right now in levitation. A guy in the 80s. You're going to love this one, because this one's going to change some rules. Let's see here in a second. I'll find out. Won't be long. So that's magic gyro. You ready?
What I really wanted to do, I suppose, was to create the means of powering a flying saucer, but somehow I could put a machine together using gyros, in which all the energy could be properly harnessed to produce a lifting force or thrust, which would be capable of driving some sort of craft through space.
And Sandy is ingenious.
The ingenuity referred to by Professor Laithwaite is built into this machine. Sandy Kid claims it is unique because it can move on its own, requiring no contact with air, water, or solid surfaces, which brings us to flying saucers. Sandy's machine is all about gyros, a gyro being anything that spins round on the end of a rod. They behave dramatically when subjected to certain forces. This gyro weighs 50 pounds and has been fired up to rotate at over 2,000 revs a minute, so that Professor Laithwaite, an expert on the subject, can demonstrate the basic concept of Sandy's device.
Very little effort required, about as much as lifting an umbrella, and no centrifugal force. Now, of course, we have the problem of stopping.
Professor Laithwaite studied Sandy's machine at the Imperial College of Science and Technology in London. Also known as an international authority on electrical engineering, the professor's know-how in gyroscopes has always led him to believe in the concept of a machine like this, a device based on gyroscopes which could produce a genuine lifting force. When he saw Sandy's invention create such an effect, congratulations were in order.
Well, it's fantastic. But there is a whole object that goes up. By whatever means, it goes up.
You see, but how does Sandy get stand then? Well, he didn't make the mistake of meddling with his first machine. He kept it. So that when he made a second machine that didn't work, he said, what's the difference between this and my first machine? It's something the first machine made better. Then he realized he'd lost some of the flexibility through the rather loose engineering of the first machine and was able to see what it was that was making it go. So then he's been able to make a better machine, knowing what it is that makes it go.
Sandy first became aware of the frightening energy a gyro can store up during rotation. One day, he had to remove a gyro from the navigation system of the aircraft.
I was walking backwards down a ladder, carrying it. Unknown to me, it was still running on its box. And the thing not much bigger than this. And then I reached the bottom of the ladder and turned round. The gyro reacted really violently and threw me on the back. I was really surprised at how much energy contained in a thing about this size. I'll never forget that experience.
Years later, in 1974, when back in Civvy Street as a development engineer, he watched Professor Laithwaite demonstrate the powers of gyroscopes during a television lecture. What he saw that evening convinced him that somehow he could build a machine to harness a gyro's energy and put it to good use.
In deciding on the basic design of the machine, I knew I had to somehow mount two gyros within a structure at a critical angle, and by subjecting them to certain forces through rotational movement, produce a lifting force through the action of the gyros.
The whole machine is designed to spin round like a top. When this happens, the gyroscopes want to fly off the end of their axles because they are being subjected to what is called centrifugal force. With the gyros themselves being driven at a very high speed in a certain direction, they react to the centrifugal force by swiveling upwards and taking the machine with them. Because of its design, it is only able to rise 2 inches off the bench, but the machine is capable of climbing to any height you want. The machine produces a thrust equal to 10 or 12 ounces, but the device itself weighs 7 pounds. To calculate this lift, therefore, Sandy devised a counterweight system consisting of a piece of string attached to the top of the machine, threaded round 2 overhead pulleys, then tied to an old vise loaded with 4-inch nails. When the machine lifts, Sandy gradually removes nails until the device starts to drop. The lift achieved is equal to the weight of the nails taken away. Now, this may all seem a bit crude, but such ingenuity is the stock and trade of the inventor.
One of the most important aspects of tackling such a complex project was making all the bits and pieces necessary and juggling them around until I learned them right. While being a toolmaker, I could make everything myself, and that was a real bonus. I could set my own pace to get things done my way, building one machine after another, getting the size of the gyros right, mounting them at the right angles, determining the rotational speed of both the device and the gyros, so that the two interacted to create the effect I was after.
Another of his many problems was deciding how he should drive his gyros. Finally, he chose a 6.5cc water-cooled model aeroplane engine and linked it up to the bottom of his machine. This engine can produce 1.25 horsepower at 16,000 revs a minute, transmitting that power to the gyros by a belt and pulley system. The machine itself is rotated by being connected up to an electric drill.
During my experiments, I brought out more electric motors than I cared to remember about. I was stealing motors out of any gadget I could put my hands on. Washing machines, lawnmowers, and things like that. In doing all this, I was working with only a very basic grasp of mathematics and physics, which of course are very much involved in this type of engineering. In developing this machine, I've been plagued with setbacks, but having been a development engineer for years, I knew full well that you rarely get anything to work first time. It was very often a question of 2 steps forward and 3 steps back. At the weekend, I simply worked on the machine from morning till night. Towards the end, I dreaded having to go out to the garage. It became some sort of hell, but I just kept going. Machine worked for all the right reasons, using all the factors I had built into it. The forces within the device were operating in a different pattern from what I had imagined. In other words, I had created a machine which I did not fully understand at that point, but which was producing the desired effect. It was in trying to establish how these forces and other influences were actually behaving that really created bigger problems than I'd encountered before.
I know how that is. Yeah. All right. The thing is that thing flies. It not because it's turning. It flies because of
18 months of building and rebuilding machines, and you had come
inertia, momentum, and it doesn't need to be fixed to anything. So that's why it can fly. And now we're going to see examples of the same technology, but not for flight. But literally, it's the same thing, except you need to build it to 2 counter-rotating, plus the 2 counter-rotating rotors need to be also spinning. So, like we've seen before, for the effect of levitation. But for other effects, also check this out. There's kids' bikes. There's all sorts of interesting things to see right now. Watch this.
to the end of the road. If it didn't work now, I knew I had nowhere else to turn. I'll never forget it. I went into the garage, started revving up, and then it happened.
Then it happened. It lifted. You're going to see it lift there, right
It
here.
lifted against the curb and stayed up. I could
Lifted.
hardly believe it. There was a feeling of sheer joy and relief. I'd done it. Cracked it.
Throughout this project, Sandy had worked alone without help from experts, not even from Professor Laithwaite, who had inspired him 10 years before on television. Now, in his hour of jubilation, he was the man Sandy wanted to give his news to first of all.
Well, it used to work quite well on that.
Professor Laithwaite is himself a great visionary, a man who has constantly sought to push back the barriers of technology. In Sandy's machine, he saw the reflection of his own beliefs.
And this would work out in space, so we're going to change the world.
I think it will, if it's allowed.
Immanuel Velikovsky, the famous Russian scientist and writer, put it this way: "What I want to impress upon you is that science today, as in the days of Newton, lies before us as a great uncharted ocean, and we have not yet sailed very far from the coast of ignorance."
Oh yeah, that's exactly right.
This is the gyro wheel. It's going to replace training wheels for kids learning to ride. Rather than teaching bad habits with training wheels on the back, you have a super high stability front tire that's running, a disc inside. This is at the highest stability speed. It's operated by a rechargeable battery, and the charge at the highest speeds lasts about 3 hours. So can I put it on the ground? You can imagine that a child who's wobbling on top of this wheel is going to feel really secure and stable. As they feel more stable and secure, you can lower the stability speed. There are 3 levels, and eventually you're going to take them off the stability altogether, and it's just going to act as a super slick looking front tire, fits on any standard 12-inch kids bike. And again, you can charge the battery as well as put air in the tire with this really easy interface. And this is an indicator light. It's going to tell you when it needs to be charged, when it's up to speed, and when it's off. It will fall eventually, but by the time it falls, the child can usually figure out what to do with themselves. So, yeah, it's great. Yeah, we've tested it with over 100. That's cool. It's awesome.
Months of building and rebuilding machines, and you had come to the end of the road.
So the interesting part is when I look at that and I combine all the ways that I know that everybody's starting to know how to build things, it makes things so much easier because now the wheels themselves are keeping the vehicle straight. You got, intelligent wheels. You have electric motors, which you don't need gas anymore. You just need a battery pack, a motor, a remote control, some smart wheels, some smart suspension, and it all fits in your remote control, and you're like, you can drive the car sitting in the back if you want to because it's all RC remote. Drone like. Next thing you know, you just put 4 motors and you make a drone out of the car because it's already built light, so it's built to fly. So if you start thinking of making vehicles for yourself, you'll end up making a vehicle that's light enough to fly. But if you want to buy it, they'll sell you a 2,000-pound car that flies. That's a bit heavy on the. You get my drift? Or they're gonna make it out of carbon, and it's gonna cost you 150 grand just to have something that actually is made like a fucking 3D printer and costs maybe 10 grand to build. Apart from the manufacturing first devices to create it, but yeah. All right. That was really the most important things for today, but we can continue and let me just do a little magic trick here. Click, 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 and here I'm going to show an image of the tube cells. So here we have, how many? 7 tube cells at 0.5 volts each, which gave me a total of 3.5 volts. So this is, this actually lights up LED lights. It's not a static device. It's actually like batteries, but you don't need to charge it. So that's my version of, well, basically it's my version of the free energy battery. Here's one that I'm having trouble reproducing, and I received the lithium battery I needed to reproduce it. It's right there beside me. It's waiting to be reproduced, but I know I have a lot of work to put into it, even if it looks easy to build. This is a self-sustaining device. It gave energy 30 watts of LED lights, which is pretty powerful, and self-sustaining itself. I call it the dual buck converter setup. It's a relooping setup, and it only works with At the time, I reproduced this many times for weeks on end. But then I didn't have the parts anymore, and then because I broke it, and then I couldn't reproduce it when I got the other parts. Basically, I didn't put the time that I needed to either. To make certain things work, it's a finest touches. It's not just plug and play. It's everything has to be the right voltage. Everything has to be relooping at the right, or else it will create an echo and it will break. It will create more energy, and it's not made. So everything has to be rethought out. Even the step-up converters, I would need to design my own step-up converters to be kind of limitless in their, well, figure of speech. Instead of being just 35 volts, I just make sure that there's 200 volts, so if it echoes, it don't break, and stuff like that. Plus the transistor was doing the right thing, but now maybe they changed the fucking transistor and it's not pulsing the way it used to. And that maybe is the reason I didn't reproduce it. So there's a lot of freaking factors. You see on the levitation device that the guy made with the two rotors before, right? He made the first device, it worked. It was working. Then he made a second one. Then the second one wasn't working. And then he realized that there wasn't flexibility in the second one. And then he realized what the flexibility was creating. But they don't say it in the video. But basically, what the flexibility was allowing the device to move into. So then he made it so it would move to that location. Basically, if you think about it. Now, that's how you discover stuff. It's like, oh, but he had kept the first device. I don't keep my first devices because I don't have the materials to continue. So I take the first device and I take it apart and I do something else with it. Because it costs money. Next thing you know, you need a part. You're like, oh, okay, I'll take it, I'll take it from there. And next thing you know, you need to put it back, but you put it aside, and you're like, oh, I have to do it back again. It's just fucking crazy stuff. But basically, if I would have help and a surrounding around me, we would change the world. And that's hopefully one day people will understand. Now, I'm going to show other devices. For example, there's configurations that are interesting. This is a 6-volt device. The star tube cells, I think I called it. There's, new principles of making capacitors out of geometries and aligning them to create field interaction that we desire, and storage in space. What does that mean? It means that when you use these devices, you're creating a static field, and the ions and all that happens around the device is actually a kind of storage mechanism. So just like a capacitor has capacitance, but if the plates are very far apart, right? One would think that it wouldn't work, but it actually works, but over time. It takes time. But that time equals also capacitance, if you think about it. So then when you're creating bigger fields and bigger fields, then the smaller fields are already in that bigger field. So now you have an inductance going on everything. If I would put it, if I put all the pieces together, the puzzle, that's what it gives me. I'm going to show you something else. I could find it here. See, these are the way, like I make energy. This has 1.5 volts of free energy, basically. So I was kind of showing how I build the layers. So basically right now, if I add another layer on this side, then it would be finalized. So I'm showing that one side has graphite, and then it's sliced with oxide on it, and then there's this piece of paper that is, in this case, wax paper, which is pretty good to use. But other materials have to be tested because there's surely something better than that. Well, the Kapton tape doesn't work so good for the tower cell, but anyway, it will work for other applications. Let's put it that way. There's a lot of things to explain, but supercapacitors is done the same way. So this was the supercapacitors working on it. I don't have all the images in front of me, but basically they always use an oxide. I use gold a lot of times. I use zinc. You know, you could use multiple different oxides. Don't combine them, but unless you know what you're doing. There's way more advanced stuff that if people would be listening to our videos, their consciousness means their conscious would be ready, and we could move forward. You know, like in doing coils that are never been done basically or before, you know, bifilar coil, in the toroid shape, you know, the type of thing of testing supercapacitors and coils and new geometries. I've coined some devices which comes with a high level of understanding, and at the basic of levels is conductivity in geometries, and it's kind of like circuit boards, but these are like just to show you like the principle of it. Okay, it's made like baby steps, baby steps. You get it? So these devices can be also are made to have energy, like they can have voltage. I can make pieces of paper with 1,000 volts if I put my time into it. I'm not joking, because voltage is easy to create. Well, easy. For me to be able to make 1,000 volts, there would be 2,000 squares on this piece of page. And they'd all be connected in a real special way. And then there'd be a separator and some nanomaterials and some graphite, and then there'd be another piece of paper with another 2,000 squares on. And then we would have 1,000 volts. But to make those 2,000 squares on that piece of paper, it's not just drawing with a pen. They're metals, they're materials. You gotta have 2,000 squares of copper, 2,000 squares of graphite, 2,000 squares of aluminum, 2,000 squares. Now I'm going big here, but I'm just letting you know that within 2 pages, 2 pieces of paper and 1 separator, right? You can make free voltage, any volts you want. Just like the magnesium cell that we saw in the beginning of this video. The same thing, boys. But you know, at the end of that, he said, well, we don't know what's in there. Well, I'm telling you, the future of what's in there. I created it. Well, figuratively as speech, because everything's already created, but when you emphasize it, emphasize realities, like it just did, then creativity opens up to new ways of understanding. Just like the new ink that is conductive, okay? But you gotta put it, you gotta be creative. You gotta go to the next level of stuff. What are materials? What are the different properties of the materials? What kind of radiation comes off of the materials? What kind of radiation is attracted to the materials? What kind of what effect does it have on magnetism? What range of frequency is it? What broad range is it? Is it in light? Can you interact with it on the frequency it is? And how can you interact with it? How does it behave in different environments? What type of environment does it create? What are the properties of those? It continues and continues. Because I understood certain things, I kind of can make a protocol of how to do things. I don't just kind of make a protocol. I make protocols. This is the protocol I call the calling cards. If you think this is a joke, look into antennas. You'll see that they all have different geometries. Okay, this is not just a power system or a frequency system or a symbolic system. Right? It's all of the above and more. It is an antenna also. And what kind of antenna, you know? Depends which one you want to make. Depends how you want to make it. Depends what concepts of your subconscious that you can create in your psyche. And then that will connect you with other consciousness that have created the same things in the universe. For example, if I would put a cross on that piece of paper, consciousness would relate it to Christ automatically. Right? So there's this quantum entanglement of all those who are thinking and looking at a cross at the moment. And there is a type of vibrational frequencies that are usually aligned with Christ. So then you are enshrined when you do look at the cross in the right eye, you know that others see it with the light of Christ. So you are part of a bigger vibration than many people. Now, if you do a swastika, most people on Earth would think it's Hitler, but really, other people would say, "Oh, it's Buddhist tradition that dates before the flood." It's not Hitler. It never was, it never will be. If I take the cross and I lift it up and I make my own religion, right? And people don't know about the true Christ. And people just learn about me, right? I'll never be the true Christ. The true symbol of that was belong to. You understand what I mean? You could try to corrupt Christ. You can make religion that corrupt Christ. You could do errors and sin that corrupt Christ. But you're not corrupting Christ. But people might think otherwise. What I mean is Christ is Christ. You can't say that the other guy fucked up Christ. Christ did what Christ did. The other guys did what they did. Big difference. The symbol of things is what you think it is. It's what you believe. Because you create your own reality. But there are the true symbolism of things. So what people think about a symbol is what it is for them. It's the truth. It's their truth. It's your truth. But it's not the truth of the symbol. The symbol has always its own truth, just like a geometry. The geometry, you know, a pyramid has 3 points. It has its own truths. You can't change that it has 3 points. A pyramid has 3 points. Figuratively speech, there's 4-sided pyramids and so on. But you get the point. The triangle, I mean. Triangle has 3 points. You can't change that a triangle has 3 points. The cross has a cross section. You can't change that it has a cross section. It means something. It's a symbol. The cross sections, right? So you could put like cross section of your body, or the cross section of the earth and the sky, and the vertical, and so on. But it always going to relate to what it is, to cross section, to lines crossing. So you can't change that. Turns out to be the same shape of the body. If you want to put a guy on a cross, it's the same dimensions of the Fibonacci. Figurative speech. It's a symbol. It is what it is. You can't change it. You can change it in your mind. People can make you believe that the swastika is Hitler's sign, right? But if you believe that, you'll never learn about its true meaning, because you'll run away, because you're programmed to. Now that, and we all are. We all are. You see, if it would have been a few years back and I would have gave this example, maybe you would mostly remember Hitler. But maybe now you'll realize that maybe you should remember the Buddhist philosophy, the cultivation practices, the Tai Chi and the yoga, and all the benefit that comes with it. Maybe that's what they wanted to hide. Maybe that's why the little devil in Hitler's ears told him to use the swastika, because they knew that they would be corrupted over time. And that if the world would see it as corruption, then the world would always turn around to cultivation. Think about how genius they are to even be able to, because it's easier, it was easier to, they know to corrupt, so it's like they offer you, they offer guns, and then they'll create the wars. They create a circumstance which is an illusion, right? Like, or a boosted up truth. Oh, terrorism, let's attack, or they give an illusion of something. We make the building fall and we blame it on this or on that. They make an illusion to give themselves the right, so the people let them do it. So the people let them create the wars, and they let their children go to the wars, and think that they're fighting their country because they don't want the building to fall down. But it's the same agencies that are protecting them that have put the buildings down, or not protecting them. But both sides of the coin would have reasons too. Some people would think that the world needs to be dominated. That if it wasn't for them, the world would end. So they give themselves privileges to go to wars. But it's based on illusions. Truths, but it's truths that it's like the swastika. It's the truth that Hitler used it, and then in theory, if you don't know anything about history, in theory you'll say, hey, that's a Nazi song, but it's not. He took everything. He even took the cross. I mean, he even took the stick that stabbed Jesus Christ. There's nothing the guy didn't take from other practices to try to gain his supernatural abilities. But he deceived himself a million times. Each time that he wanted to do that, he became weaker and weaker. For a man to need so much to believe in something, come on. Anyway, it's a joke. big freaking show. Freaking communism. And if we let them continue, we got to make sure that we're heard, because if we're not, then it's their voice, and their voice ain't worth shit. They torture people. They don't give their law, they don't follow their own laws, and they're against humanity. They're against all that it is to be a true human. Hurting another individual has nothing to do with being human. That would be unhuman. So we gotta stop letting people hurt other people, because it's not human to do that. And now that people are doing it, then the whole fucking world thinks it's human to do that, and it's really not. So, everything's upside down, kind of, guys. A lot of, I was about to say, a lot of slapping around still to do. I leave you on a beautiful day, and knowing also that your heart is the creation. Let yourself imagine, because there's nothing that you can imagine that isn't real. Peace. Understand.